So today we're looking at section 2.4, deductive reasoning. This is something that you probably have not thought of in math before, so it is going to be something that is truly different for you. Deductive reasoning definition. It's a process of reasoning logically from given statements or facts to a conclusion. So you start out with a statement, you're going to use facts and things that you know, you're going to come to a conclusion, which makes sense, but maybe not so much, in a math class. This is what I would like you to write down. You can put it into your notes right now, but you can put it back into your postulates and theorems pages, even though it's not a postulate or theorem. I'm going to let you use it anyway. So the law of detachment, P arrow Q, what's the arrow mean again? What kind of statement is it? If-then statement. Yep. So you start with an if-then statement. The next statement is just a letter, which means it's just a single statement. And then the little 3 dots right there, that stands for therefore. So it's basically a symbol that, takes out the word therefore and just puts 3 little dots in there. So first statement, if-then statement. Second statement is just a regular statement. Third statement is a regular statement as well. So just some key things to look for. Eventually, when we do a couple more of these, you'll have to identify what kind of law they're trying to use. So that's why I'm kind of pointing out what you should look for. And it's called the law of detachment. I think I have it on the formula sheet already. I think. Yep. So you don't have to memorize it. It can be in your postulates and theorems, but it also is on the formula sheet. If the second given statement matches the hypothesis of the conditional, then you can make a valid conclusion. And we're going to look at that. This won't make any sense to you right now until we actually look at one that do have sentences, so you can see which part needs to be the same, which part does not. Okay, so second given statement, that's your P in the second row. If that matches the if part of your if-then statement, then you do have a valid conclusion, and that's kind of what it means. But it almost is more helpful doing an example so that you can kind of see how that works. Okay, so problem 1, what can you conclude from the given true statement? Okay, so this is kind of a lot. The book likes to put them kind of all in one kind of paragraph. I like to think of them in 3 separate lines. So if a student gets an A on a final exam, then the student will pass the course. That's the whole if-then statement. But we need to figure out in that if-then statement which part is P, which part is Q. And you can just leave it back there, Josh. Thanks. So the if part, a student gets an A on a final, is P. So if it is on a worksheet or something like that, I definitely encourage you to underline and label your variables. Then the student will pass the course. So I'm going to change colors just so you can see it better. So the pink part is the Q part. Now, if you identify what those are, the next line should tell you if it's a valid conclusion or not. So then it says Felicia got an A on her history final exam. Is that talking about the P part or the Q part? The P part, yep, because it's talking about getting an A on the final. But the thing that you might notice is it's talking about a student to begin with, and then it's talking about Felicia. It's just a specific student, so it's fine. You'll know when that isn't an okay thing. Usually when they're using law of detachment, they do talk about specific people in the second and the third line. So this part kind of replies back to the student, and that's okay. But she got an A on the final exam. That goes back to the P part. Okay, so our conclusion would have to be Q. So here's what the form looked like to begin with. P arrow Q, P, therefore Q. Is this following that so far? We had an if-then statement. My second statement talked about P, which is fine. So my conclusion needs to talk about Q. So I need to talk about the student passing the course. And which student is it? Felicia. So my conclusion, and remember that stands for therefore, Felicia will pass the course, or will pass history. You can do either one. Okay, so you need the statement that I put right here. Don't put in a lot of extra words than are already there. Just go with whatever it says. Since the Q part was talking about passing the course, if you put course there, it's okay. If you put history there, it's okay. Each one is talking about the same thing. What can you conclude from the given true statement? Now this one changes it into a little bit of geometry stuff, so it makes it a little bit harder. If a ray divides an angle into two congruent angles, this is P, then the ray is an angle bisector. That's Q. So far we have P arrow Q. Generally, if they give you an if-then statement at the beginning, that's what P arrow Q is. So according to the form that we're looking at, we need it to talk about P next, and then our conclusion will talk about Q. If something is wrong about that, then there isn't a valid conclusion. Okay, so let's see if this one matches. RS, and that's actually ray RS. Is that okay so far? If a ray divides, so we're good. They're talking about a specific ray, and that's okay. Divides angle ARB into two congruent angles. Have they done that? Yep, they're just being specific about it. So this actually is my P part. It corresponds to P, so I'm going to underline it in pink. And that's P. So I need to write my conclusion talking about the Q part. Okay, well the Q part is the ray is an angle bisector. Which ray are we talking about? Ray RS. So you do have to be specific when you're talking about these things. Ray RS is an angle bisector. And that would be your conclusion. Now, remember when you guys wrote out that big long thing that said, if the second statement talks about the first part of the hypothesis, there's a conclusion. Well, what happens when it doesn't? Okay, so I'm thinking in the next example or two, they're going to give you one that doesn't work, and I'll kind of show you why. What can you conclude from the given true statement? If two angles are adjacent, so two angles are adjacent is the P part, then they share a common vertex, that's the Q part. It says angles 1 and 2 share a common vertex. What part does that correspond to, P or Q? Q. Is that in the correct order? No. That's how you know if it's valid or not. So you look at that form that you guys wrote down. It's supposed to be P arrow Q. The next line is supposed to be talking about the first part. The conclusion is supposed to talk about the last part. This one went out of order. It is not something that we can have a valid conclusion for. So we're going to say invalid. You can also put no conclusion there. If you need a reason, you can get very specific and say the argument should have talked about the angles being adjacent first or something like that. But basically, if it doesn't follow this format, it is not a valid conclusion and it's not a valid argument. So I'm just going to say it doesn't follow law of detachment. Okay, so you can be very specific about the reasoning if you want to, but to make it short, sweet, simple, if you can name the argument that it's supposed to follow but isn't, you're good. Okay, it doesn't follow this style of law. Okay, here's another one. If there's lightning, then it is not safe to be out in the open. Maria sees lightning from the soccer field. We need to come up with a conclusion. So, P, there is lightning. Q talks about it not being safe. Okay, what does Maria sees lightning from the soccer field go with, P or Q? Okay, so that so far is okay, right? So if it follows that, then we can come up with our conclusion. So we're going to say, therefore, Maria is not safe to be out in the open. So the only thing I changed from that second part of the statement is to make it specific because they're talking about Maria. Not everybody else, just Maria in this one. Had they said Maria isn't safe to be out in the open, then it would be invalid because they're talking about Q first. They need to talk about the first part of the if-then right away. If you put it in words, we can think of it like this too. If it would have said Maria is not safe to be out in the open, could there be other reasons why she's not safe? Yeah, that's why. So according to this one, you have to keep it in the right order so that it kind of follows and it makes sense. Here's the second one. If a figure is a square, then its sides have equal length. So the P part is a figure is a square. The Q part is its sides have equal lengths. Then it says figure ABCD, that's a specific figure, has sides of equal length. What part does that go with, P or Q? And is that the correct order? No. No. So we're going to say invalid. Doesn't follow law of detachment. You can also put no conclusion, doesn't follow law of detachment if you want to. So what do you think about these? Are they kind of okay? As long as you can specify what P is and what Q is, makes it easier. If you don't know what you're doing there, it's going to be hard to come up with a conclusion if you don't do that. I think the book will probably have you write out what is P, what is Q. But even so, you can make it shorter if you want to. You could do P square, Q equal length. You can make it shorter if you're just trying to distinguish which one is which. You don't have to have every single word included until you're actually filling in what the conclusion is supposed to say. So I'll kind of show you one where you actually have to write it in. And we'll do that here in a second, okay? Now, I also want you to write this one down. You can write this in your postulates and theorems. Make sure you name it, law of syllogism. Notice in this one you have 3 if-then statements. So should it be easy to tell which one is which? The first one only has 1, and it's in the first sentence, and then you have 2 shorter statements after that. This one has 3 if-then statements, so it should be pretty easy to tell which one is which. And there are more. I took a class in college, and there's lots more. They just kind of want to give you a little taste of what this is, and it's just reasoning. But there are a lot more of these that are a lot harder to figure out what they are. We're just kind of giving you a couple. So if P then Q, if Q then R, therefore if P then R. All if-then statements. I want to kind of show you how you can figure out what that last one's supposed to be. Notice how this one ends in Q and this one starts in Q. Those need to be the same. Notice the things that are not circled are the conclusion. So the thing that you've talked about already should be repeated. You're going to do the first part of the first statement, the last part of the second one, that's your conclusion, okay? And it's pretty easy, like once you've done a couple, that will make sense. Right now, I'm just gonna put these 2 statements are the same. And we'll use it. This allows you to state a conclusion from true conditional statements when the conclusions of one statement is the hypothesis of the other. You don't need to write that down. It's just kind of explaining it. Okay, what can you conclude from the given information? So if a figure is a square, then the figure is a rectangle. If the figure is a rectangle, then the figure has 4 sides. I'm going to make it just a little bit smaller. Okay. So we're going to break down the if-then statements first. So on the side, I'm going to write P. And what does that have to do with? The if part of that first statement has to do with what? You can just put it on the folder. Thanks. Yep. So if a figure is a square, can I just put square? You want just the basic idea. If you want to write down every word, you can. The only thing is don't include the if part because the if isn't attached to it. It's just that starting thing. So I'm just going to kind of underline what that first one has the idea of. So I'm going to put P has to do with square. Okay, so the Q part is going to be your then part. It has to do with being a rectangle. I'm just going to put the shape of a rectangle. We'll go 2 lines for that. Kind of like subject predicate for English. Do you still do 1 line, 2 lines? No? Okay. That's for the first one. Now you got to do the same thing for the second one. So I'm going to switch colors. If the figure is a rectangle, so here it's going to be, what part was that, Q or P? Q, so I'm going to put Q, rectangle. That's the first part, right? Was that the order that it's supposed to be in? So far, yep. Then the figure has 4 sides. Is that something the same as we've already talked about or something different? Different, right? We haven't talked about having 4 sides yet. So I'm going to say R, 4 sides. Okay, so here's what we have, and I'm just going to do it in symbols just so you don't have to pay attention to the words. So my first sentence said, if P, then Q. My second sentence started with Q and went to something else. So my second one is Q, arrow R. Is that okay so far? Yep. So my conclusion is going to be, and I'm going to write it over here so I can have a little bit of room. I need to do if P, then R. So my conclusion needs to be P arrow R, and I need to write it in words. So this is the only part that you really have to make sure you write it in all the words. The rest of them can be just little tiny thoughts. So if a figure is a square, then what do I write last? We need the R part. What was R again? 4 sides. Then the figure, or you can say it, has 4 sides. Okay, so pick it apart and make sure that you use like just a single word if you can. Just the idea will help you decide what it's supposed to be. So remember that these two were the same. So when you're reading it in your head, it's going to work as long as what you last said in the first if-then statement is the first thing in the second one. As long as those two match, it will work. Okay, what can you conclude from this one? Okay, so we're going to say if you do gymnastics, gymnastics is going to be P. Then you are flexible. Flexible is going to be Q. Okay, and it can be just a single word. If you do ballet, have we talked about ballet yet? No. That's going to be a different letter then. So I'm going to say ballet is going to be R. Then you are flexible. What's flexible again? What letter? Q. Okay, now we're going to put it together. So here's what my argument looks like. If P then Q, that looks good. Then it said if R then Q. Is that correct? Which letters were supposed to be the same? The last part of the first one and the first part of the second one. These two were supposed to be the same, right? They are not. This one does not follow the law of syllogism. We're going to say it's invalid. You can't come up with a conclusion. Okay, and basically you could explain the words as well. Just because the person does ballet doesn't mean they're flexible, right? For the most part, ballet people are flexible, but what if it is a kid that is just starting? Maybe it's somebody that is 32 years old and they're trying to do ballet, they're probably not going to be flexible. So you could use words as well. Just because you do ballet doesn't mean you're flexible, okay? Or a good gymnast at that. Okay, what can you conclude? What's your reasoning? Okay, so far right now, if then, if then. So I think it's syllogism. They haven't had you guys make a decision, but that's what you're looking at. So if a whole number ends in 0, P, divisible by 10 is going to be Q. If a whole number is divisible by 10, what does that go with, P or Q? So we're going to go with this one, Q. Then it's divisible by 5. What does that one need to be? R, because it's a new idea, right? So we have whole number ending in 0, divisible by 10, and now we have divisible by 5. That's something that's new. I'm going to put an R in there. As long as the middle two letters match, you can make a conclusion. So we're going to say if a whole number ends in 0, I don't count it wrong if you don't have the little therefore, by the way. If a whole number ends in 0, then it is divisible by 5. And that would work, right? If I had 60, can you divide 60 by 5? Ends in a 0. If I had 20, 20 ends in a 0, 20 is divisible by 5. So every single number that ends in a 0 is going to be divisible by 5. Okay, if I switch those two and I said if a number is divisible by 5, then the number is divisible by 10, would that one work? So if I said the number 35, is 35 divisible by 10? No. Then that's why it's false, is because when you switch them and they're not in the right order, it doesn't work. Okay? And you could give a counterexample there. Okay, here's a geometry one. These are always just a little bit harder than the others. But if you stick to the PQ, thing, you'll be fine. If ray AB and ray AD are opposite rays, that's going to be your P part. The two rays form a straight angle, that's Q. If the two rays are opposite rays, does that go with P or Q? Okay, so I'm going to change back to green. Then the two rays form a straight angle. What does that go with? Are the two middle letters the same?
No.
No. Isn't it just kind of a repeat of the same thing? It's just basically the if-then statement repeated. The first one just happened to be specific. The second one was not. So I'm going to say invalid. Doesn't follow syllogism. Okay, so when you're looking at it, the two letters in the middle have to be the same in order for it to work. This time one was a Q and one was a P. Here we can use the law of detachment and syllogism together to make a conclusion. These are definitely harder. So let's look at one that's just a little bit harder than the other. What can you conclude from the following? Okay, if you live in Accra, then you live in Ghana. Okay, so there is a map if you want to look at. I can maybe make it a little bit bigger. We'll go like this and then we'll go back to the map. Okay, so if you live in Accra, then you live in Ghana. So Accra is that red little dot. Ghana is the country. Okay, so here we're looking at this one. That's Accra, you live in Ghana. Okay, if you live in Ghana, then you live in Africa. Is that true? Ghana is a country in Africa. Alyssa lives in Accra. Okay, we want to know what kind of conclusion can we make. Okay, so let's just start underlining the P and the Q part. You live in Accra, so I'm just going to underline Accra. That's going to be P. Ghana is going to be Q. Okay, what's the second statement have to do with? P or Q? Ghana stands for Q, right? Is that okay so far in the if-then statements? Yep. The two letters in the middle need to repeat. Then you live in Africa. That's a new idea, so I'm going to put R there. But then they switch it out, and then they get specific about a specific person. Okay, so it looks different, doesn't it? So initially they had the if-then statements. They were going well. Basically, you're going to talk about somebody that lives in Accra and conclude that they live in Africa because the middle two letters are the same. The only thing they're doing is they're getting specific with the person. So Alyssa lives in Accra. That's talking about the P part. So we're going to assume that she lives in Africa. So we're going to go Alyssa lives in Africa. So do you see how they kind of combine the two together? The first two statements were if-then statements, so that was kind of the syllogism. And then they broke it down and they grabbed a specific person that lived in each. Okay, so you can combine the two. They don't do that as much, but just so that you know you can do that. Okay, and this one is kind of another one of those. I'll just make it a little smaller. If a river is more than 4,000 miles long, that's P, then it's longer than the Amazon, that's Q. If a river is longer than the Amazon, what is that, P or Q? Because those match. And is that okay so far? Because those match. Then it is the longest river in the world. Is that a new idea?
Yes.
Yep, so let's go pink there. The Nile is 4,132 miles long. Okay, is that more than 4,000 miles long? Yep, so it's still following what we need, because since these two letters match, our conclusion needs to be talking about whatever P is and whatever R is. It's just that in this one, they're getting specific about a specific river. So they've already said the river that is more than 4,000 miles long. We can assume that the Nile is the longest river in the world. Okay, and that's your conclusion. Now, how are you going to know if it does that? They're going to give you more sentences than you normally have, right? So this one gave us 3. Normally they give you 2, and then you have to come up with the conclusion. So if they ever give you more than 2, that's when it's a combination one, and that's going to be how you decide, what to do. The first part of both of these were if-then statements, and then they translated it down to a detachment argument after that. And that's it. So did it seem like math? It seemed kind of like English, right? Where things have to be in a specific place. So if you can look at those law of detachment and law of syllogism and pick apart just ideas, you're going to be fine, and then you write your conclusion. Your conclusion is the only part that has to be word for word, pretty darn close to what it said. If you're looking at identifying the letters, you can pick one word from it as long as you know what the main idea is of that P part of that statement. It's okay. So you don't have to get real wordy with your definitions. It just needs to be wordy when you get to that conclusion.